Hey there everybody, this is a video for my 40S Intro Calculus students, and this is going to seem a little strange compared to what we've been doing lately, especially because it's blurry. There we go, now it's back. Yes, delete everything I just threw into the recycle bin. Thank you very much, computer. What was I saying? Oh yeah, this is going to seem like, what? We were in the middle or at the beginning of Unit 2. It was 2.1. Aren't we going on to 2.2? Yes, we are. But the textbook that I stole the 2.1, 2.2, 2.3 for from has a little unit on this earlier in the textbook that we didn't really go over. It. Actually, it's in the beginning of the textbook, kind of in the grade 12 review section. So we need to kind of go through this before we get too much further into Chapter 2. We need to talk about something called composite functions. Quick refresher, remember that a function is a rule. I like to think of a function like it's a machine, where you throw something into the machine. This is a machine right here. That's my drawing of a machine. And you throw into the hopper here, you throw in an x, and then something happens to the machine, and out comes f of x. So if the machine's rule is, say, x squared, then you put in 2 and out comes 4. If the machine's rule is 2x squared, you put in 2 and out comes 8. And if the machine's rule is square root of x minus 1, then you throw in 2 and out it's going to come 1, etc., etc. It's like, to me, a function's kind of like a toaster. You know, you put in bread, right, and you put down the little things there and you push them down. You put in bread. That's bread to me. Wow, I can't draw bread, I just realized. You put in bread, and then you push down the things, and out comes toast. And everybody remembers from grade 10, oh yeah, on a graph, you test for something that's a function with a vertical line test. If the vertical line hits it more than once, then it's not a function. And people forget what this is really just a visualization of a rule that's really important, and that rule is that a function has to be, for each input, there is a unique output. Oops, I can't spell output. Output. What I mean by that is, obviously, if I put 2 in and my rule is square root of x minus 1, I have to get 1. I can't get anything other than 1 when I put in 2. Right? Imagine if I put in 2 and sometimes out comes 1, and then sometimes out comes 4, and sometimes out comes a billion. That'd be like my toaster. I put in bread and sometimes comes out toast. I put in bread, then the next time comes out a bagel. I put in bread, the next time comes out a Pop-Tart. That sounds really exciting, but come on, let's face it. If that happened to you in your kitchen, you'd be like, demon toaster! And you'd be like getting a priest and an exorcist or something. Well, same thing with functions. If I don't get the same thing out every time I put the same thing in, it's not a function. So that's really kind of what that vertical line test was all about. It was a shortcut way of making sure, when I plug in this x value, there's 2 possible things that can come out of the function. Machines don't work that way, toasters don't work that way, functions don't work that way. And now that we've refreshed that idea, we're going to go and talk about composite functions, which means what happens when we put functions inside of functions, which sounds bizarre, but it's actually pretty cool. I'm going to start with this guy, or these two guys. F of x is 2x, and g of x is 7 minus x. And you don't have to write this part down. You didn't have to write any of the last junk down. You should maybe write this down. But I'm going to actually restrict their domains. I'm going to restrict the domains of these things. So domain restriction. Domain is going to be, we're going to go just from x is 0 to 6. And if you're not a big fan of interval notation, remember you could write that as x is greater than or equal to 0, less than or equal to 6. But if you're going to use that notation, you got to do it all fancy and use the fancy brackets that I suck at drawing. There we go. Okay, so, and if you're going to do that, you know what else? I'm actually not going to count all the decimals and stuff. I'm just going to say that x is an element of the whole numbers. So, using just whole numbers from 0 to 6, let's make a table of values, shall we? Haven't done one of those in a while. So let's make a table of values. So x could be 1, 2, 3, 4, 5, or 6. So copy along and make yourself a table of values. There we go. So what happens to f of x when x is 1? Well, 2 times 1 is 2. What happens to f of x when x is 2? 2 times 2 is 4. What happens to f of x when x is 3? I think you get the pattern. Now what about my other function? What happens when you plug in 1 to this function? 7 minus 1, well, that's 6. 7 minus 2, okay, that's 5. And once again, I think you see the pattern. But now, here's something that perhaps you've never been asked before in this setting, or maybe you did a little bit of this in grade 10, but it's probably been a while. What's f of g of 2? Well, I can use my chart. What is g of 2? In other words, take g of 2's answer and put it in for f of x. So g of 2, the function g of 2 is when x is 2, g of 2 is 5. So what's f of 5? So this is like saying what's f of 5? And f of 5 is when x is 5, the input's 5, the output is 10. So the answer is 10. Now that's not the only way I could have found that. I could have found that algebraically. I didn't even need this chart really. I could have found it algebraically by going, okay, g of 2 is 7 minus 2, which is 5. And then f of 5 is 2 times 5, which is 10. That hopefully isn't too tough. And there's yet a third way I could have found this. I could have found f of g of 2 by actually finding what f of g of x is as its own formula, and then plugging 2 into the x of that formula. So what does f of g of x look like? Well, f of g of x would be plug g of x in where x is. So it would be 2 times 7 minus x, which is 14 minus, well, I'm off the page, 2x. And if that's f of g of x, f of g of 2 would be to plug 2 into 14 minus 2x. And 2 times 2 is 4, 14 minus 4 is 10. Look at that, 3 different ways to get 10. Isn't that exciting? Okay, why don't you try this one? Find g of f of 2. Will it also be 10? Will f of g of x equal the same thing as g of f of x? Probably not, but try it. Try it all 3 ways. See if you can get it from the chart. Then see if you can get it by just figuring out f of 2, plugging that number in and getting g of 2. And then see if you can do it this algebra way where you actually find g of f of x. Okay, I'll give you a sec. Pause the video and try it. All right, did you try it? Let's use the chart, see what the number is. From the chart, g of f of 2 is, well, f of 2 is 4, and g of 4 is 3. So I'm getting 3. All right, what's g of f of x? Let's get a formula for it. G of f of x is, I'm going to plug f of x, which you can't see, into where the g is. So that's going to be 7 minus 2x. So I'm replacing x with f of x. So 7 minus 2x. And if I want g of f of 2, that's 7 minus 4, which is still 3. So, oh, and I froze. My hand moved too fast. I heard Bruce Lee had that problem when they had him shooting a television show. He moved so fast the cameras would freeze. That's what I have in common with Bruce Lee, apparently, right there. So, that's fairly easy to navigate, eh? There's nothing all that earth-shattering about what we're going on here. We're just plugging functions into other functions. And there is a shortcut way to write this, which we'll get to in the next example. Actually, maybe we'll mention it now. F of g of x, which, right there. Oh, wait a minute. No, that's not where it is. Oh, there it is. F of g of x has another name. F of g of x can also be referred to as f little circle g. I know that looks like I spelt the word fog. I wasn't trying to write the word fog, but you know what? Most people, very often, people just nickname this fog. And sometimes it's also written as fog, in a bracket, x. And that says the same thing. It says f of g of x. Take the function g of x and put it inside f of x. Put your toaster inside your microwave oven. Actually, now that I've said that, I realize that's a dumb thing to say. Please, at home, nobody put their toaster in their microwave oven. You'll burn down your house. Don't do that. Okay, do these instead. Your turn. Pause the video and give these two a try. If f of x is x plus 2 and g of x is x squared, find f of g of 3. And remember, that's like saying find f of g of 3. And there's a couple ways you can do it. You can plug 3 into g of x, get an answer, plug that answer into f of x. Or you could do it the algebra way. Find an equation that represents this first and then plug 3 into it. I don't really care which way you do it. On your mark, get set, go. Did you try it? You should have got, let's see, I'm going to do it the number way first. I'll plug 3 in here. 3 squared is 9. 9 plus 2 is 11. I'll do it the formula way now. I'm going to plug g of x into f of x, which is going to be x squared plus 2. So that's f of g of x. And then I'm going to find out what f of g of 3 is. And that's going to be 3 squared plus 2, which is 11. And my pencil needs sharpening. So while I'm sharpening my pencil, why don't you try B? Find f of negative 8. Sorry, g of f of negative 8. Okay, did you try it? F of negative 8, back here, negative 8 plus 2 is negative 6. So negative 6 squared is 36. And again, if I wanted a formula way to do this, g of f of x is going to be x plus 2 squared, squared, and that's going to be x squared plus 4x plus 4, and if I plug negative 8 in here, I get 64 minus 32 plus 4, which is 36. Actually, I shouldn't write it like that. I should write, look at me skipping steps like I own the place. I should write, that's that, and, oh, thanks, Norton. Glad to know you're on the job. That's that, and then g of f of negative 8 would be plug negative 8 into here, right? Nobody likes it when you skip too many steps. And that would be positive 64 minus 32 plus 4, which is 36. So there we go. This is interesting. What do you think f little 0 f 4 is asking you? My pencil's kind of too light for this. I think I'm going to switch to a pen so it's easier for you to read, which means no mistakes. The pressure. Okay, what does this mean? F O F 4. Well, it actually means f of 4, which means figure out what f of 4 is, plug that answer back into f of x. Oh, that's cool. So go up to f of x. F of x is x plus 2. So what's f of 4? 4 plus 2, which is 6. Now plug 6 in. What's f of 6? 6 plus 2? 8. Is there an algebra way to write f of x? Or f of x, same thing? And the answer is yeah, sure. You can actually plug a function into itself, which is x plus 4. So when I started with 4, I get 8. Okay, if that makes sense to you, why don't you pause the video and try that? What's g of f of 3x plus 4? Did you try it? So I want to know what g of f of 3x plus 4 is. So first of all, I need to know what f of 3x plus 4 is. So that's going to be g of, and f of 3x plus 4 means I plug 3x plus 4 into x plus 2. So that is going to be 3x plus 4 plus 2. And I might as well tidy that up a bit. That's g of 3x plus 6. And now g of 3x plus 6 means I plug 3x plus 6 into g of x. So that's going to be 3x plus 6 squared. And I could probably leave it like that, or if you wanted to, you could multiply it out. It's 9x squared plus, what's 18 doubled? 36. 36x plus 36. Is that right? 3 times 6 is 18. 18 and 18 is 36. Yeah, it is. There we go. I don't really care, though. This would have been a good answer, too. Okay, so there's kind of the first real example. I actually didn't call this one an example. I called it a your turn. So the next one's going to be more of a your turn. See, look, you get lots of turns. Your turn some more. If f of x is equal to x squared, but I'm going to actually restrict its domain, just like I did with that chart one at the first page. So f of x is equal to x squared, and normally you could plug any number you want into x squared, but I'm going to stick to numbers that are between -3 and 3, and my range is going to go from 0 to 9. g of x is going to be 2x plus 4, but once again, my domain is -3 to 2, and my range is -2 to 6. Once again, I want you to try this yourself and see what you get. So, okay, take a second and give that a try. First of all, find g of f of -1. Did you try it? So f of -1 is putting -1 into this number and squaring it. So -1 squared is 1. So this is really like saying g of 1. And when I plug 1 in here, I get 2 times 1 is 2. 2 plus 4 is 6. No problems. That's a fairly easy one, I think. Next, find f of g of 0. Okay, what do we mean by f of g of 0? Well, we mean exactly that. I would like to find f of g of 0. In other words, find g of 0, take that answer and plug it into the f function. So g of 0 is, first of all, is 0 in my domain? Yeah, 0 is between -3 and 2, all good. So 2 times 0 is 0 plus 4 is 4. So this is like saying f of 4. But hold on a minute. 4 is too big to plug into f of x because f of x only goes from -3 to 3. Aha! So that would mean this does not exist. I know you're probably thinking, but I can plug 4 into this formula all day. 4 squared is 16. Next. Nope. If there are restrictions on the domain and range of one function, you have to respect those domain and range restrictions when you plug them into the other function. So another good way of thinking about this is to actually go back to the first page, to the chart guy. Remember the chart guy a minute ago? What if I wanted, I'm just going to use a scrap piece of paper. Is this scrap paper? Close enough. I'm going to ask you to find f of g of 6. Can you find f of g of 6? Well, let's see. G of 6 is 1, and f of 1 is 2. Yeah, no problem. What if I asked you to find, so that's 2, okay, that's not a problem. What if I asked you to find g of f of 6? Okay, f of 6 is 12, g of 12, wait a minute, 12 isn't part of g's domain. I have no idea what g of 12 is. I have to ignore the actual equations and just look at the domain in front of me and say, nope, does not exist. Okay, back to new examples. We're done that one. Okay, that's enough of the your terms for now. New example. F of x is equal to 1 over x. G of x is equal to x squared minus 4. Find f of g of 2. All right, let's try that together. Well, g of 2 is plugging a 2 into here. 2 into here is 2 times 2 is 4. 4 minus 4 is 0. And f of 0 is 1 over 0, which is, aha, undefined. So once again, f of g of 2 does not exist. So there's another reason why sometimes a composite function might not exist. You end up not just beyond the domain and range that you've established or been told to set up, you might actually end up with the good old divide by 0, which we've been talking about the whole course, does not exist. How about B? Find the domain of f of g of x. Okay, well, let's see. F of g of x. So remember, fog means f of g of x. So f of g of x would be to put g of x into f of x. So that's going to be 1 over and replace this x with x squared minus 4. So what's that? So what's the domain of that? Now, do you remember how to do domains? You did this back in grade 11. Domain would mean, tell me all of the possible things x can be. There's 2 numbers x can't be, right? The non-permissible values here are that x cannot equal plus or minus 2, because if I plug positive or negative 2 in here, I get division by 0. So that means that the domain is, well, I could go from negative infinity up to, but not including negative 2, together with, what would see, negative 2 up to positive 2. But notice those are curved brackets, which means you can't actually be those numbers. And then together with, you could go from 2 to positive infinity. Okay, and again, that's interval notation. If you'd rather have that in set notation, you'd have to say, well, let's see, how do you write that in set notation? Well, if you want to be really fancy, it's x such that. X is less than or equal, no, it's not less than or equal to, it's just less than, right? It can't be 2. X is less than negative 2, because you can go to infinity, but it's greater than, no, wait a minute. X is greater than negative 2. I just goofed that up. Can I start that over? Thank you. I'm going to start that over. X such that. Let me start that again. When I think about it, I could say that it's x is less than negative 2. You know what? I have to do this in steps. I can't do it all in one statement, I just realized, because it's 3 parts. Duh. Why didn't I think of that? X is less than negative 2, and then I'd have to say x can be between negative 2 and 2, and then I can say that x is greater than 2. So there we go. Boy, that's a lot of writing. You know what the easier way to write it is, and I don't mind if you did this, you could just write, you know what, x can be any real value except it can't be plus or minus 2. Haha. Please write it like that from now on. So anyway, that's the domain. One of those answers would be good. I guess I kind of like the interval notation best. So the domain is this guy here can be any single number in the universe you want except plus or minus 2 for x. So that's its domain. Now, let's think about it the other way. Right? What about find the domain of I don't remember why I didn't write a C question here. Find a domain of g of f of x. So let's do it the other way. So g of f of x would mean plug the f into g of x. So that's going to be 1 over x squared minus 4, which is going to be 1 over x squared minus 4. And for that one, the domain is, and let's write it the easy way this time, and let's get Norton out of the way again. Jeez, Norton. Norton's very attention-seeking today. I would say that, okay, what's the only number in the universe x can't be here? And the answer is 0. So x cannot equal 0. This is my domain, obviously. But it can be all reals besides that. Okay, and again, if you wanted that in interval notation, you'd say you can go from negative infinity up to, but not including 0, together with 0 not included, to infinity. Okay, so there's a domain question. That's example 2. Example 3 is kind of more of the same. Ooh, you know what? Let's make this a U try. Pause the video and do a U try on this one. If f of x is 4x minus 3 and g of x is the square root of x, solve for x if f of g of x equals g of f of x. Cool. Give that a try. This is a neat problem. So let's pause the video and give it a try. Did you get anywhere? Okay, well, let's see. F of g of x, I'll write it this way, has to equal g of f of x. That's cool. Okay, f of g of x means plug g of x into where the x is in f of x. There, that's this one. G of f of x means the opposite. Plug f of x into the x for g of x. If you didn't know how to start the question, pause it now and see if you can finish it from here. Did you give it a try? What's your next step? It's to square both sides. So if I square this side, it's actually kind of easy. That's just 4x minus 3. It just cancels the square root. But this one, I have to FOIL that. I have to multiply this by itself. So it'd be first times first, which would be 16x. Outside times outside plus inside times inside, which is minus 24 root x. And then last times last would be plus 9. Sorry, I'm kind of writing all wavy. Geez, you'd think the lines on the page would help, but they're not. So there you go. Isn't that an interesting looking equation? What am I going to do with it? Well, I'm trying to solve a radical, so I'm going to move everything that isn't this radical to the other side. So negative 24 root x is equal to 4x minus 16x, which is negative 12x, and negative 3 minus 9, which is negative 12. I've got a nice little equation here that every single piece of it, every single term, is divisible by negative 12. I'm going to cancel that out. I'm dividing both sides of the equation by negative 12. So 2 root x is equal to x plus 1. Once again, I've got a radical on this side, so I'm going to square both sides again, giving me 4x is equal to x squared plus 2x plus 1. And then I'm going to move 4x to the other side, so x squared minus 2x plus 1. That factors very nicely to x minus 1 squared. And then I square root both sides. I move 1 to the other side, and I think x is 1. Isn't that interesting? Now, we could check our answer by plugging 1 into this side and seeing if they balance, and spoiler alert, they do. But you know how else we could do it? Yep, you guessed it. At this point, you're probably asking yourself, is he ever going to make a video where he doesn't go to Desmos? No. So here we go. Oh, I forgot I actually did this example too, but I'll go back to that one. So here, we're over here. This is the first one, 4 times root of x minus 3, and this one is the other one. And you can see they meet at 1. When x is 1, they meet. Ta-da! Isn't that cool? Yeah, you know what? I kind of forgot that I put these on my Desmos too. What was the last example? Let me just go back to the last example for just a second. Sorry to go backwards on you here. But going back to example 2, if f of x is 1 over x and g of x is x squared minus 4, you can tell Desmos, you can say, Desmos, I want to do f of g of x graphically. And you can. Here's f of x. It's my good old two-armed 1 over x graph. You should know what x squared minus 4 looks like. It's a parabola with a y-intercept at negative 4. There it is. But together, if I put g of x into f of x, I get this, y is f of g of x. That you can't use the little fog notation with the little circle on Desmos, at least if that command exists. I haven't found it. But there it is. There's both of them together. And as you can see, that is what this guy... Oops, I'm on the wrong page. That is what... There we go. That's what... No, that's not that guy. Oh, yeah, that's that guy. That's what this guy looks like. He has a nickname in math. We call him the driveway graph. So that is 1 over x squared minus 4. And you can see it. It's called the driveway graph because it's like a car that's pulling into a driveway. Don't see it? Well, use your imagination. It's like the constellations, you know. It's like, really, those 8 dots are a hunter with a bow and arrow? Yes, they are. You got to use your imagination. So this is a car pulling into the driveway. It's the driveway graph. What's important about it is, of course, what it has. Remember we said we have some non-permissible values here? Remember that in the equation, let me go back to it again. In the equation 1 over x squared minus 4, there is, again, 2 non-permissible values. X cannot equal plus or minus 2. On my graph, that is the asymptote at x is negative 2 and x is positive 2. Non-permissible values are actually what we call vertical asymptotes. Hopefully that's something you remember from grade 11. And the other one, what if we went the other way? So again, we started with 1 over x and a parabola. And what if we put the 1 over x into the parabola? Then we get this guy. Some people call that the volcano. I call it the Atari. Check out Atari's logo. That's pretty similar. And it makes sense that this is basically a 1 over x. Yeah, this is a 1 over x squared minus 4 graph, right? This is g of f of x. So I plugged 1 over x in here. So it's 1 over x squared and then minus 4. And there it is. Cool. Okay, a couple more examples, and we're done for today. So let's see. We did that one as a U try because it was fun. And a couple more here. Example 4. Given f of x is equal to x minus 4, can you find f of... Ooh, what does that mean? F to the negative 1 of x? Now, for those of you who've done grade 12, you probably remember this. You saw it a little bit in grade 11 too. That's called an inverse. What is the inverse function? And you find the inverse by basically switching domain and range. So, in other words, you switch x and y. I'm going to borrow a symbol from chemistry there for a two-way reaction. So, if f of x is equal to x minus 4, remember that you can replace f of x with just another variable like y, is kind of the traditional if we're thinking about a grid, right? X and y. And then switch their places. Here is the act of making the inverse. The range becomes domain, the domain becomes range. And then from there, what does that look like as an answer? Well, from there we can kind of look at it and go, okay, well, I might want to rearrange that into what it would look like. What it would look like if I rearranged it so that y was first. So y would equal x plus 4. So therefore, f to the negative 1 of x. And again, that's just like a symbol that means inverse. It doesn't mean I'm actually taking the f function to the exponent negative 1. It means I inversed it, and that is equal to, as we just said, x plus 4. Remember, the other place you've seen that is when you had, cosine of theta is a half. Theta is the inverse cosine, is what you'd say, of a half. I'm not taking a cosine to the exponent negative 1. Cosine's not a number that I can take to an exponent. That's an inverse operation, an inverse function. So same thing here, inverse function. Now that we've remembered what an inverse function is, check that out. What is f of negative 1 of x? In other words, what is f of negative 1 of x? So I just figured out that f to the negative 1 of x is x plus 4, so I want f of x plus 4. So I'm going to find f of x plus 4. I'm going to go back to my original function, which was x minus 4, and I'm going to plug in x plus 4 for the x. So that's going to be x plus 4 minus 4. Oh, interesting. That's x. Interesting. What about here? What if I did it backwards? What if I found f primed of f of x? So I'm going to plug f of x into f prime. So f of x is x minus 4, and I'm going to plug that into x plus 4. So that's going to be x minus 4 plus 4. Oh, that's also x. And guess what? We can generalize that. That tends to be true, that f of f primed, or sorry, not primed, f of f to the negative 1 of x will indeed always equal x. That's actually a rule, and it comes in handy sometimes when you're trying to prove things. Okay, so that's 4a and b for example 4. And example 5, decomposing. Like everything in math, once you learn how to use it forwards, we want to see if you can do it backwards. What if I know I have this big function, call it capital F, and it's actually f of g of x? And I tell you that this function is this. So this is the composite of two functions. What are they? Ah, interesting. Well, let's see. What two things? What could I put inside? So f of g of x has to equal the cube root of x plus 5. Well, think about it this way. It's like I put x plus 5 into the cube root of x. So I think that what I can say is that that means that g of x must be x plus 5, and f of x must be the cube root of x. And then do a double check. If I plug that into this x, I get that. Now, that's one answer. Is it the only possible answer? Actually, no. I'm just going to tell you another possible answer and see if you can understand why it works. F of x equals x to the 3/2, and g of x equals x plus 5 squared. See if you can figure out why that would be just as good of an answer as this one. See if you can figure out why when you plug this into here, you get that composite function. All right, so that's the quick little lesson on composite functions. I handed out a composite functions worksheet in your last class, so you can now give it a try. The assignment is on the blog. Thanks for watching.